All right, today we're going to dive into a paper that really gets to the heart of a billion-dollar question in AI. It's all about the art of scaling reinforcement learning, and it offers a pretty radical solution to one of the industry's most chaotic and expensive problems.
So let's just get right into it. The whole paper is trying to tackle this really frustrating paradox that AI labs everywhere are dealing with. Why does making AI smarter so often feel like you're just pouring millions of dollars into a complete black box? It's this high-stakes gamble where, just adding more money and power doesn't actually guarantee you're going to get a better result.
To get a handle on this, let's use an analogy. I want you to think of it like baking a $1 million cake. You've got all the best ingredients in the world. That's your data, your compute power. But what if you didn't have a reliable recipe? You'd just be stuck with pure trial and error, which, let's be honest, is a recipe for incredible waste.
Okay, so what's causing all this chaos in our AI kitchen? Well, a huge part of the problem comes down to this one specific process called reinforcement learning.
You see, AI training usually happens in two main phases. First, you've got pre-training. This is kind of like the AI just reading every single cookbook on the planet. It learns all the fundamentals, and this part is actually surprisingly predictable. But then you get to reinforcement learning, or RL, and this is where the AI tries to perfect one specific, really complex recipe based on feedback. And this is where all the chaos kicks in. It's always been way more art than science.
The reason pre-training is so predictable is because of something called scaling laws. These are basically rules that guarantee that if you add more compute, more ingredients for our cake, your model will get better in a predictable way. The huge problem has always been that reinforcement learning was totally missing these basic laws.
So, to finally crack this code, a team of researchers decided it was time to stop all the guessing and start actually measuring things. They launched this massive experiment to finally write that missing recipe for RL. And when I say massive, I really mean it. They poured over 400,000 GPU hours into this thing. To put that into perspective for you, that's like leaving a top-of-the-line gaming PC running 24/7 for over 45 years. Yeah, this was not a weekend project. This was a monumental, systematic investigation. And all of that incredible effort was focused on one single, really clear goal: to replace all the guesswork with a real scientific framework. They wanted to understand, to analyze, and this is the most important part, to predict how an AI model gets better with reinforcement learning. So what did they find after sifting through all that data? Well, their huge experiment led them to three surprising, honestly game-changing discoveries that pretty much turn our old assumptions completely on their head. The first big insight is that your starting point, it's everything. It's just like baking, right? If you have a flawed recipe from the start, you can't just fix it by baking it for longer. Some of these training methods have a built-in performance ceiling, and no matter how much more compute power you throw at it, you're just stuck. You can't get past that limit. The second discovery is just as crucial. You know how researchers are always obsessing over these tiny little tweaks in the training process? Well, it turns out a lot of those tweaks don't actually improve the final quality of the model at all. They might change how fast you get to that performance ceiling, but they don't raise the ceiling itself. This really helps separate what's essential for quality from what's just about, efficiency. And this third discovery, this is the real breakthrough. They found that with a good, stable recipe, performance doesn't just grow randomly, it actually follows a predictable curve. This is the absolute key. Because if you can run a small, cheap test to just plot the very beginning of that curve, you can then accurately predict its entire path. You can forecast exactly where it's going to end up at a massive scale. And suddenly, all that chaos reveals this clear, predictable pattern. So armed with these three powerful discoveries, the researchers didn't just stop and publish a theory. Nope, they created a practical, best practice recipe to put it all into action. And they gave it a name, Scale RL. As they say right in the paper, this is their proposed best practice recipe, a real, concrete set of guidelines built on everything they learned. And to prove that their recipe wasn't just some theory, they put it to the ultimate test. They scaled up a single training run using Scale RL to an absolutely staggering 100,000 GPU hours. And the result? It performed exactly as their small-scale predictions said it would. It worked. So how does it actually work? Well, it's a beautifully simple, three-step process. First, you build your initial recipe using only the most stable and high-performing parts they identified. Step 2, you run a small test to see how it's doing and plot the beginning of that predictable curve. And then step 3, you use that curve to confidently predict the outcome and scale up, knowing your investment isn't going to be wasted.
So what does all this mean for the bigger picture? I mean, this is way more than just a new technique. This is a major shift for the entire field of AI.
What this research really does is it transforms reinforcement learning from an art form into a science. It takes the whole process from one of guesswork and inefficiency to one that is principled, predictable, and way, way more efficient. It's about finally trading that gut-feeling intuition for hard data.
The real-world impact here is just enormous. It means AI labs can now innovate more reliably. They can stop burning through millions of dollars on experiments that go nowhere. And ultimately, that means they can speed up progress towards building more capable and safer AI for all of us. This finally tames that wild, chaotic process of RL and brings it in line with the predictable science of pre-training.
And that leaves us with this final, really exciting question. For years, the insane cost and risk of reinforcement learning has been like a brake on innovation. So now that that brake has been released, what new ambitious frontiers can AI researchers finally start to explore with confidence? The possibilities are really just beginning to open up.